Welcome to qnawire.
738 is a fun little Atwood machine problem. We have two blocks with different masses that are attached to either end of a light rope that passes over a light frictionless pulley suspended from the ceiling. The masses are released from rest, so that's what I put in dotted boxes here. And the more massive one starts to descend, and I label that one as big M and the little mass as little m. After the block has descended 1.2 meters, its speed is 3 meters per second. So the total mass of the blocks is 22 kilograms, what is the mass of each block? So we're going to be using work to solve this. So I'm going to first write down the equation that we're going to eventually solve, and that's going to be the work done by gravity, because it's released from by rest, and it goes down and it moves, and gravity does a certain amount of work in order to give the masses kinetic energy. So that's what we're going to be solving. Okay, so first off, what we're going to do is we're going to find how much work gravity does. So we have work done by gravity is equal to the force times the distance for each of them. So we have the mass of the big one times g, that's the force, and the force is going to be in the same direction as the displacement. So we have positive 1.2 meters. And then for the other one, we have a different force, little m times g, but it's going up, so it's against gravity. So we have minus mg, little mg, 1.2 meters. Okay, so then what we're going to do then is we're going to simplify this a little bit. So we have big M minus little m, g, 1.2 meters. Okay, and then that's just going to be our difference in potential energy from the first state to the second state. Okay, so then our K is going to be the kinetic energy of the masses. So we have 1/2 big M velocity squared. So that's going to be 3 squared. And it's going to be plus, because kinetic energy has to be positive, plus 1/2 m. Okay, so here's one important note, is that because these two masses are connected by a string, if one mass is moving 3 meters per second down, the other mass has to be moving 3 meters per second up. So that means that we have 3 meters per second squared here too. I'm going to rewrite this as 1/2 big M plus little m, 3 meters per second squared. Okay, so we know what the sum of the two blocks is. So that's going to be 22 kilograms. So that when we substitute that in, we're going to have 1/2 times 22. That's 11 times 9. We're going to get 99 joules. Okay, now since we have this value here and we have this here, we can just write what that is. So I'm going to continue by writing big M minus little m times g, 1.2 meters equal to 99 joules. And then when I solve that, we get big M minus little m is equal to 12.11 kilograms. So now we have an expression for the difference of the masses equal to some value. And what I'm going to do is, in order to find what the big mass is I'm going to write what this total mass of two blocks is. So I have big M plus little m. That's going to be equal to 22 kilograms. And now what I can do is I can take these two equations and add them together. And I get 2m is equal to 34.11 kilograms. Okay, so then we have our big mass. We just divide by 2. That's going to be equal to 17.0 0.05. We're not caring too much about the rounding here. Kilograms. And that means that when you take the sum of the 17 plus 0.05 plus something equal to 22, we get our little mass is equal to 4.95 kilograms. And that's going to be our answer there.